Welcome to Adopting Zero Trust, an independent podcast that dives into the world of zero trust and tells the story of people who are adopting it. Throughout our series, we'll investigate why zero trust is becoming a critical concept for cybersecurity. Our hosts, Elliot Volkman and Neil Dennis, will have transparent and open conversations with the people driving modern security approaches forward, while leaving vendor hype behind. It's time to remove implicit trust and buzzwords and get to the root of the movement.
Hello, everyone, and welcome back after a short hiatus for AZT. I am your sleep-deprived producer, Elliot Volkman, along with our hopefully well-rested and maybe well-vacationed host, Neil Dennis, along with Zack Butcher, the founding engineer over at Tetrate, but he also contributed to two NIST elements that we're going to be discussing a bit today. And then also just some of the other items, considering he works with a technology vendor that wraps around zero trust. I'm sure you're more than equipped to be able to kind of have some conversations around what the market's looking at. So we'll jump between the two of those. But that said, Neil, how's it going? How's travel?
It's been a busy couple of weeks, man. Travel was great. Vacation was great. Unlike you sitting there with, a tiny hoodlum that you have to manage that's screaming in your face, feed me, feed me. But yeah, I wish I could say I was well rested. Managing a conference right now for a shameless plug, but Texas Cyber Summit here in Austin. I haven't slept in literally 2 days. So this will be a fun conversation, Zach. I am. It's all to get at, brother. So we're good to go.
It'll be a good one. I'm looking forward to it.
Excellent. So typically, this is a good point for us to let Zack introduce himself, just to give a little bit more than what I can see on LinkedIn. Zack, obviously, you have done a little bit more than be the founding engineer for a startup, but you have a pretty interesting background. Obviously, you worked over at Google, but some other spots. So maybe tell us a little bit about yourself and how you have found yourself in your shoes.
Yeah. I actually, funnily enough, my career started all the way back at a company that most people never had heard of before, but now I'll say the name in just a second, and probably everybody that listens to this podcast will recognize it immediately. My first job out of college was actually working for a Colonial Pipeline company. Now, I didn't do any security stuff there, but of course, everybody immediately perks up as that was the company that had the ransomware attack that triggered the executive order mandating the zero trust stance. For me, that was kind of a funny full circle thing to have happen, right? I actually was already working with NIST on microservice security standards at the time then the Colonial Pipeline breach and ransomware event happened. And so it was kind of funny for me to look back and see, obviously I chatted with some of my old buddies there and they were not having a good time. But, for me, that was cool. After that, I moved and worked at Google on Google Cloud. I kind of jokingly say I built all the enterprise stuff in GCP. So if you go to Google Cloud, you make a project. That was my baby for a long time, projects. And I was there on the team when we shipped the organizational hierarchy, orgs, folders, the identity and access management system with hierarchical permissioning there. A lot of that stuff, the service management service. We then, as part of that team, rolled out the service mesh architecture to 100% of workloads at Google. And that was in from 2014 into 2017 or 2016 or so. We finished that up. And around that same time, obviously, Kubernetes was hitting its stride, and we were seeing a lot of networking-oriented problems, a lot of security problems, and eventually into some of the zero trust things we'll talk about in a minute, out in the space. And obviously, we had solved a lot of those inside of Google in various different ways, but with that service mesh architecture fresh in mind, that's when we created, and I was one of the earliest engineers to join the Istio team there at Google, where we, kind of brought the service mesh architecture into the fold. So jump forward, and that's kind of what I do a lot with Tetrate today. So I was one of the founding engineers there. I was one of the, our CEO and co-founder was the original product manager for Istio over at Google. And I wear a bunch of different hats. I work on Envoy community things. I work on service mesh stuff, but most relevant here, I help a lot of large organizations adopt service mesh and some of the security posture therein. And I work with the federal government on two sets of SPs. On the SP 800-204 series, that's the series that offers guidance on microservice security. And on just very recently, in fact, about 2 weeks ago, it was finalized. It's been in draft review for a few months. SP 800-207A, which is the most recent installment in the Zero Trust series. A lot of folks maybe recognize SP 800-207. That's the big Zero Trust granddaddy one that was mandated by the executive order and all that. 207A is the first or the next installment in that series, much more narrow focus, and we can definitely dig into that today.
Yeah, and I honestly, I think that's a really good starting point for us to kind of dig into, and then yeah, Neil, I'll let you kind of go down whichever rabbit
Yeah,
hole you choose. But yeah, maybe you can give us a little bit of context of what is contained in there, how it
yeah.
advances what has previously been published.
Yeah, so obviously, 207 and the existing stuff that's been published by CISA and NIST around it and the cybersecurity framework, there's a huge amount of material because zero trust is a huge area topic, right? 207A, like I mentioned, very focused. And in particular, we focus only on runtime. And I would argue that's maybe the easiest part, right? I know you've had past speakers on the show talk to, the cultural change, the people process change. That's the hardest part. However, when we talk about zero trust at runtime, there's a lot of FUD and a frustrating
Mm.
amount of FUD in the marketplace and a lot of vendors claiming certain things or zero trust and not. And in that landscape, I wanted to really kind of push for people a very clear definition of zero trust at runtime. And it's a minimum definition. Let me be clear. You can do a whole lot more than what we talk about in the SP, but I try and give a very, very simple minimum definition. And that is 5 policy checks at runtime. And we call that identity-based segmentation.
Hmm.
So there are kind of 3 ideas that the SP introduces. Identity-based segmentation is the first and the most important one. And those 5 policy checks at runtime, hopefully y'all will nod your heads along when I say them, because I think, for this crew, they should be pretty self-evident. 1, we need encryption in transit. And we need that for message authenticity and for eavesdropping protection. Right. So we want to make sure nobody can eavesdrop and nobody can tamper with the messages that we're sending. Second, we need an authenticated service principal. So we need to know what are the software systems that are communicating, and we should use that authenticated principal to authorize the access. We should have an access policy that says the front end can call the back end can call the database, the front ends cannot call the database. Then the additional 2 policies that we want on every hop are, in addition to those 3, are the end user needs to be in session and authenticated. And we need to perform authorization on the resource that end user is accessing in this context, in this set. Hopefully, nothing, and especially the user side of it should be very straightforward. Hopefully everybody, and certainly if we've been in government space, we've been doing things like FIPS compliant encryption anyway. Hopefully maybe the only novel pieces are some of the, and even then it's not new, is that service authentication and authorization, right? Fundamentally, the reason we propose those 5 as a minimum runtime check is because the heart of zero trust is the idea that the attacker's in the network, right? So if you have a perimeter-based control, it can already be bypassed. I happen to give a talk about 207A in DC and in downtown in the Ronald Reagan building in the Federal Triangle. And that morning, earlier this year, in fact, we found out that the U.S. federal government released that China had compromised multiple networks in the Pacific, right?
Yep.
Now, it's a beautiful case study, and a motivated attacker can get inside your network, right? I promise. And so then the question from a security perspective becomes, how do we mitigate the risk, right? How do we bound an attack in space and in time to minimize what they can do? So that's the whole ballgame that we're playing. So my argument is that those 5 runtime controls, and we make this argument in the SP, is that, those 5 runtime controls help you effectively bound an attack in space with authorization policies to limit pivot, and in time with ephemeral credentials that need to either be restolen or will expire out, right? So you either need a persistent attack and you're limited in what you can pivot there, or you need to continually perpetrate some theft of credentials. And so all of it's about shrinking the gap, right? Shrinking, we want the attacker to have to get through Swiss cheese, the holes in the Swiss cheese. We need as many layers as possible to make it as hard as possible to get through those gaps. That's the goal. Identity-based segmentation, those 5 checks, we argue absolute minimum that you should be doing. And if you're doing that, then I would argue you can call it a zero trust system. One other little piece I'll give you is the mental framing, the attackers in the network. The other way that I try and frame that for people to think about is, suppose that I can just pick a system, any software in your infrastructure, and expose it to the internet. What is the impact of that? And when you can tell me with a straight face that the impact of that is the risk is minimized, because I have a variety of other controls. So it's not catastrophic that this is internet facing. Then I would argue you're in the right ballpark for zero trust, right? And so I would argue those 5 policy checks: authenticating, authorizing the applications communicating, authenticating, authorizing the user, having that all encrypted, should give you a pretty strong guarantee that if I'm going to go expose this application to the public internet, it hopefully is pretty safe. Right? That's the mental model we want to operate in.
Yeah, I'm going to start poking a little bit.
Please.
No, so I think that's awesome. I mean, that's a cool overview of the deal. So it also saves me from having to go back and try to read it. No.
Fortunately, it's a little bit easier to read than most too. I'll kind of pat myself on the back here. But it's only about 12 pages of content. So one thing, when I say it's focused, one of the goals here is that like 207A is a couple hundred pages.
Yeah.
207, we're trying to keep these things short and sweet and focused so it's easy to read. So please, and I say that as hey, please, if you're a practitioner in this space, go check it out. This is one of the easiest ones to read. So sorry, little plug there.
So I also want to say this is really, we've had some authors, we've had some book writers and some other stuff. We had some people who've contributed to policy, but I don't think we've ever really had like a legitimate person on that's actually is the policy, right? The person who authored, wrote, created, guided this. So especially at this level of a standard. So first off, one, I think that's pretty epic, whether, all the stuff you're sharing relative to how that works. Thank you for all that. Cause I think this is really cool to have someone with this cool, unique perspective. And I know that's partially why Elliot made sure we had this chat. That being said, I'm very curious so we talk about the standard, we talk about some of the fun stuff, and you talk about services, right? And I'm going to kind of bridge the gap here between this and a little bit of your company background, but I'm very curious about the microservices and quote, microsegmentation and things like that, right? So I know your company, that's a focus, right? I get that. Yeah. So I would love to start with your official definition of microservices, because while it is technically a definition, let's be fair, that it's something that fuzzes around. So I would love to hear that first, and then depending on where you go with this, I'm going to bring us back over to the standard that we're talking about as well, potentially.
Yeah, for sure. So services itself, I actually hate the term microservice. I think that's kind of a misnomer. That I also, just to be clear, I hate the term zero trust. And in fact, I listened to some of your earlier podcasts, and you mentioned zero implicit trust. I actually tried very hard to change the name to zero implicit trust. That's the right thing. So bravo on that one. I hate that name, hate the name microservice as well. That's not the important part. Micro puts the emphasis on the wrong thing.
Yeah.
The important part is not the size of the service. The important part is the mode of communication. In a monolithic or a non-service oriented architecture, where we tend to communicate over procedure call, right? Local. In a service-oriented architecture, we now have remote procedure calls that are in RPC. It changes everything, right? And for me, it's not microservice, service, whatever. The important part is that this is a thing that exposes a contract over the network that it's enforcing and it's implementing, right? So that for me is the more important piece, rather than like, what is a microservice, right? What is a service? It's the application that we're running that exposes some interface over the network to be consumed by other parties, whether that's a first party in the same org, second party, like a partner API that we're going to trust each other a little bit, or something like a SaaS that's a third party and an untrusted consumer, right? Regardless, doesn't really matter. The mechanics are the same. And in a lot of respects, actually, the thing that we need to protect and the controls that we want to put in place are going to be very similar. I would argue that actually, when you're in that world of everything is a third party, that's another way that you can use that definition of zero trust, right?
Cool. Thinking about this a little. So first off, awesome definition. Thank you very much for unintentionally agreeing with my brain pan on where this should go. I love that. So I'm kind of curious. So when we think about, your 5 tenets here and the goals here for how all this really meshes together at this nice, cool strategic level that you've explained. One of the things I like to keep coming back to is, and we talk about these services, these programs and remote stuff. And everybody always thinks API, right? So that's obviously very front of mind piece and process. Yeah. So one of the things that I've seen the last year or two has been, focused on either revamping how API works, or at least becoming more aware of what your APIs are doing, right? So from your perspective, what's your kind of hot take on this based off the tenets that you discussed around where API is going to potentially go from a security perspective or just a utilization perspective, and what people should think about that, and I'll caveat this by saying I'm a firm believer that there needs to be a net new change in how we approach API, not just the security, but just the overall construct of what that is. So I'll throw that out there.
Yeah, yeah. I actually, I would probably agree with that, right? So like the API is going to be the lingua franca that we talk about, right? So we're going to move, and this is kind of part of the whole purpose. I'll come back to that in just a second. Let me touch on microsegmentation you asked about earlier, because this plays into then that whole idea that we're moving up the stack. And, microsegmentation is fundamentally a network oriented thing. When we get into API surface and API security, now we're in different nouns. Right. We're moving up, I would argue. And so I think that will be the key noun in the future that matters critically. Let me talk on microseg first, and I'll come back to that. So microsegmentation is a really important capability, right? It can provide quite a lot of controls or quite a lot of assurance. But again, it's fundamentally network oriented. And so you're placing implicit trust because of the privileged location that you reside at. I'm going to allow you to do a thing, right? So obviously that's in tension with the definition of zero trust that I gave, and that definition of 5 things for identity-based segmentation. Didn't even talk about any of that. That's actually the second big point that we make in 207A. So we introduce identity-based segmentation. I told you there are 3 things that we talk about. The first is identity-based segmentation. The second is what we call multi-tier policies, or maybe, more practically, what we call existing in the real world with real policies that are already present, right? And so we make the case that you can't, yes, you should do those 5 policy checks. And if you do those should be enough, but you probably can't get rid of your network oriented controls today. And there's a bunch of different reasons for that, right? The auditors and the regulators don't like it. You have a piece of paper written in 1994 that's your corporate IT security policy that says that you need a perimeter, and changing that paper is more expensive than paying Cisco for firewalls. Right? Like there's a bunch of reasons that we have this corrupt that we can't just get rid of network oriented controls, nor do I think that would be a great idea, right? Even if we can have supplementary controls that take their place, there's still a value in defense in depth. And so how do we trade off, and how do I see microsegmentation versus this stuff? I see them as complementary, but the key point that we make when we talk about multi-tier policy is that you should feel justified in relaxing lower level network controls in exchange for tighter identity-based controls, if that gives you more agility as an organization. We actually have a picture in the example that I use, it appears in the ST as well. Let's think about going from on-prem to cloud, and we typically go through a firewall. We probably go through 2 firewalls. We go through an outbound firewall from the on-prem side, and we go through an inbound firewall on the cloud side, right? And so now if I want to consume, let's say a SaaS database, or maybe part of my organization has shifted into cloud and I'm still on-prem, and I want to consume functionality there, the way that most organizations do that is with a pairwise firewall rule. A new app wants to consume it on-prem. That's a new firewall rule to allow the connectivity from its microsegment to wherever the thing is deployed on cloud. Historically, that's a big cause of slowdown in organizations. It's very common that with a lot of financial institutions that I work with, I'll ask this question because I know the answer already. I say, how long does it take you to change the firewall? Right. And not once has anybody said anything different than 6 weeks. Right. How long does it take? It takes 6 weeks. You go to the spreadsheets, you go, right. And it's a huge hamper on the ability to use and consume services in cloud to get agility. Like, why are we doing the whole microservices thing? To go faster, to get more agility, to get features into customers' hands faster. And if our security policy is standing in the way of that, we need to fix it. And what we propose in this SP, and we have examples there, is a pretty simple model is one mitigation for this. Put identity-aware proxies on both sides. Author a static set of firewall policy that says the 2 identity-aware proxies on either side can communicate. And then use an identity-based policy to govern which applications can go over that tunnel. If you squint really, really hard, it's actually kind of like a VPN. So what does a VPN do? It links, we have 2 networks. We say there's these privileged gateways that are allowed to talk to each other, and they control who can go over the gateway to communicate, over the bridge to communicate on the networks on either side. We're doing a very similar conceptual thing, but at the identity layer, right? So it's not your own IP address, so we trust you. It's you present an authenticatable runtime identity. I can apply an authorization policy on it and you're allowed. Therefore, I let you over the bridge. So that's one example where we relax in network control. We still have a firewall rule, but we don't have pairwise rules for every application. And in exchange, we've augmented it. We've added an identity aware policy governing who can go over that identity aware bridge. And as a result, we see organizations move a lot faster and are able to update those policies more readily. One thing I'll just touch on real quick, why can they update the policy faster? Because humans can't read IP addresses. Like I get a CIDR range. What does it mean? What's the app on the CIDR? Who knows? That's why I go look in the spreadsheet, right? So instead, when we're doing things at an identity level, it's much more evident. I can see that this is the front end application running in a particular namespace, and I can read that as a human. And so maybe I still need to go verify in my spreadsheet because names drift over time and things. You're right. But I have a much higher assurance that I'm not going to screw it up versus trying to map those CIDRs, right? And so that's one of the reasons fundamentally we can go faster. So that's kind of the second key idea. So now we're moving up to identity base to take you back to API surface and API security. So yeah, API surface. So API in my mind is going to be the new thing because it's all about, how did I define service? I was very careful not to say API when I defined service.
It's the question.
But most of the time as we're moving up the stack, I think we are going to be in an API centric security world. Right. So, and part of the reason for that is just how does an external actor, a threat actor, a friend, like how does somebody interact with the system? Your API. So that is fundamentally, so if you're not reasoning about your protections at that layer that the user is interacting with it, you're not going to have the right policies in place. You're going to have gaps and you're going to miss it. Right. Even just basic stuff. So one example of an API, because I actually when we talk about multi-tier policy in the SP, we only talk about network and identity. There's way more, right, of tiers of policy that we may want to apply. Application tier policy is one of those. And the example I actually give is something that an API gateway traditionally does, which is request validation, right? So there's huge classes of errors of just malformed requests, right? And so just simple, straightforward policy like I have a Spring Boot app. It has a well-defined request payload, and I want my Spring Cloud gateway to verify that the incoming HTTP request conforms to the schema. There's a lot of security that you can get out of something simple like that. There's a lot of large classes of attacks that you can avoid with simple validation like that, right? And even just basic things like that, we need to start to think about and do across the board. To back to the original question, API is going to be the key now. That it comes when we start to talk about securing things, because that's the unit that identities are going to act on the system.
No, that makes sense. Like I said, you are very much like me. I have a big thing I need to go through to get there. And this is good because this is where the knowledge transfer happens. So thank you, because this is following along with how my brain path likes to consume things. So I appreciate this. And once again, I love this, dude. You write the stuff, you know the stuff. You're not just making some up stuff for a company. You're not just going into a company to be like, hey, look at me, I'm Zero Trust. And we've only had a core group of people that are truly living, breathing the constructs here, and as their facts of life. So I love this. Yeah. I want to get that out of the way again. I'll probably say it another 4 or 5 more times because I'm seriously with the nature of what you're talking about. So that being said, we think about this, and I think it's really cool from your perspective on the API side of the house, and once again, why I bring it up, the stuff at RSA this year and stuff that you see in the flavor that is API security, this API security, that. So if we think about this wrapper, right, if we think about the growth with API as the goal, do you see, API is as much of a protocol for communication as it is a security layer within respect to how it's approached, right? Do you see either side of that being reapproached, overhauled, revamped in respect to this growth phase, right? And I mean, if so, what's your thoughts on that relative to where you're going with, with the constructs here? I'm harping on it a little bit just because it's been a very big focal point for a lot of people lately. So if we think about API, right, we think about where we're going with the constructs, and like you mentioned, it's probably the next big wave of stuff, right? So let's say if you go back and we rewrite, the standard again, or we approach the standard with API as a focal point, right?
Yeah.
Where do you see things maybe highlighting changes or requirements for API to go one way or the other, or does it, right? I mean, like I said, one side it's a comm structure, one side it's a security structure to get things done. So do you see any of that needing to change, producing change, or growing in one way or the other?
Yeah, there's going to be a bunch of change that happens here, and a lot of it's actually going to be around tooling, in my opinion, right? So one of the key things is going to be actually that tooling to help with the translation between those two views of an API definition, right? So exactly, I like that view, right? One is the security view. What is the thing? What is the functionality that it's exposing, and how do I access it? And what does it look like on the wire, right? Usually only one of those is up to date. Right. Well, actually, most of the time, none of them are up to date unless we can generate it from our code. Right. And then only one of the two is up to date. And usually that's the API definition, the communication structure, because I hopefully compiled it in code and my code can describe it. Again, I used Spring Boot as an example earlier, but Spring Boot produces an open API spec, for example. Right. So first off, I think we're already seeing tooling that operates on those structures. Right. First off, I know that there are plenty of API security and endpoint security vendors that will do things like accept an open API spec and use that for certain styles of analyses. For example, there's one that exactly does that style request validation that I mentioned earlier, right? That's a very common one where there's a crossover because that a lot of that's about the structure, the communication. I need it to be but there's a large security implication there too. I see a lot of tooling that we need either to exist or is being created today to help bridge the gap between those two. Just to give you a quick idea, as an example, I work with service mesh stuff. Service mesh does not natively understand an open API spec. It doesn't understand protobuf either, or any of whatever the interface definition, the IDL that you pick for your API is, it doesn't understand it. Right. Some of the things that we do at a product level are exactly like take an open API spec and program the service mesh accordingly. Right. And add some points where you can hang policy with simple annotations, for example. Right. So that's one example of what I think will become more common, which is tapping into the communication definition, the open API spec that describes what it needs to look like on the wire, and then using tooling to derive policy from that. Right. That can be simple things like the request validation, but I think we also see other more complicated things embedded in. For example, there's an entire authorization section in Open API spec. I'll keep harping on Open API spec because it's kind of the lingua franca here, but this is true of many different IDLs that you could pick to define your API, right? Open API spec has an entire authentication and authorization stanza that you can put in there, right? Now, is that the best place to put that data? Or maybe not, right? You could do things like say, hey, I want to do an authorization. And if you're going to call the read method, if you're going to call a get method, HTTP method, you need a read scope and mappings like that. I tend to like that kind of thing because I think that it gives developers and the security team a common language, right? So the other big problem that I see all the time is what I call the blank page problem, right? Like I'm an app dev. I was told to write a security policy. And so I go and open up Visual Studio Code and it's a blank page. And now I need to go find the YAML online that I can copy and paste in. Right. And so I think anything that we can, and that's one of the biggest ways, by the way, that we get viral bad patterns perpetuated inside an organization. Right. I need this config. So what do? I go to the Git repo where I know that one project 3 years ago had the config. And I copy the 3-year-old config with the 3-year-old default and I move it over, right? This is one of the biggest ways that we get bad patterns in the code base and just perpetuated that are almost impossible to stomp out in large works, right? And, anything that we can do to avoid the blank page, I think is huge. As a security practitioner, as a platform guy, as anything we can do to avoid that blank page problem and start people out in the right spot or closer to the right spot is going to pay off dividends. So I look at being able to leverage things like, here's the API, here's what my program exposes, and my program can tell you it. Take that and have Spring Boot spit out the open API spec, add a few annotations there, and I don't have the same blank page problem. I don't have to say, what does my API do from scratch? I say, this is what the API does. Let me go to the one place and change it. The mindset for a developer to do that is world different. And so that becomes a much more tractable problem than to actually get them to participate. So that's why I think we need a lot of tooling and things that play with this API world, right? Because we're only ever going to be on the side there. It's primarily the developers building it and iterating on it. And so we need to figure out, and from a security side, how do we tap into their workflows and processes to be able to get the stuff out that we need in the system and create a baseline of security, right? That is as high as we can get. Service mesh is like one way of doing that. And I mentioned some ways that we can do things like pull API spec and enforce some behavior. There's plenty of other, there's any number of other systems you can do the same thing.
Cool. No, that's awesome. So I got maybe one or two things. So I really kind of want to dive down the service mesh piece a little bit more. You kind of gave us a really good definition to kick off, but I'd really like to talk a little bit more about all that stuff, because from a structural perspective, I'm personally aware of it a little bit, but it is a relatively net new construct for my brain.
Exactly. Yeah. Happy to talk about it. Definitely. Yeah. And in fact, actually, that's how my relationship with this started. So how did I happen to be the guy that gets to co-author some of these papers? We actually started with NIST studying access control. So I mentioned I worked on some of the access control in Google Cloud. I got a nice little plaque there from a very shitty 6 months where we shipped IAM to everybody. Learned a lot about identity and access management there. And when you start to look at the service mesh, just for everybody who's not familiar with the architecture, architecturally, it's pretty straightforward. What we do is we take a traditional web proxy, a reverse proxy. Envoy is the CNCF project that we use, but think, Nginx we could have used for the same way, for example. We take that reverse proxy and we put it as a sidecar next to every instance of every application. And when we say sidecar, what we mean by that is, just like a sidecar on a motorcycle, it's deployed in the same domain. So if we're in a VM, that proxy is on the same VM that hosts the application. If we're in Kubernetes, it's in the same pod. And it's going to intercept all the network traffic into and out of the application, thereby being what we would call policy enforcement point, a PEP, right? So if you're familiar with stylized identity access management systems, in fact, the term PEP goes all the way back to the 70s and the initial idealized access control architectures, right? They introduced the PEP and the PIP and the PAP and the RAP and all these different 3-letter T things, the policy enforcement point, the resource access point. That's where we started. But the service mesh we saw, because it's intercepting all the traffic into and out of the application, as a perfect universal policy enforcement point. The second piece of the service mesh, so we had those proxies beside every application intercepting traffic in and out. The second piece of the service mesh is the control plane that programs it. So this is where we push configuration, and the control plane is going to go and distribute that configuration down to all of those sidecars that are deployed across your infrastructure. So that's really what the service mesh is. So now you can imagine when you're sitting there intercepting all the network traffic, you can do a whole lot of stuff. You can do encryption in transit. You can do per request policy. You can do routing and traffic decisions. You can do observability as well. So you can get a really nice comprehensive picture of what's talking. You can give identities to those things. You can start to apply authorization policy on those things, right? If we think back to identity-based segmentation, I said there's 5 controls: encryption, service auth in, service auth C, end user auth in, end user auth C. The service mesh really is very well suited to do the first 3 of those. And it's suited to be a good integration point for the other 2. So when I say it's a policy enforcement point, we can do things like authenticate the user, that's a policy. Authorize the user, that's a policy. Do a 1% traffic canary, or only send user agents with iPhone to that instance, that's a policy. We can do all of those things with the service mesh. And again, it gives you centralized control. So I don't need to go change those settings per service, although I can, but I can change them globally in one place and have them affect the entire infra, right? So that's kind of the superpower, and that's what's different. We needed security and observability and traffic management before. The service mesh gives us it in a way that is universal no matter what the runtime of the program is, and with centralized control. Now, I mentioned I do the access control research. So obviously as a policy enforcement point, we can do access control there. But the thing that really got the folks at NIST excited about the service mesh as an architecture, again, goes back to some 1970s research. And if we talk about the kernel, so where does the operating system kernel come from? It comes from a set of ideas about the security kernel. That's where the kernel name comes from. And the idea is, of course, what we do with the kernel today. If you're a Unix process and you're running on the Linux operating system, you have a certain set of security guarantees provided for you by the system. And specifically, it's the kernel that implements those guarantees. It gives you things like user spaces and namespaces and C groups and all these other abstractions of use. The folks at NIST were excited because they saw the service mesh as potentially being the kernel or the security kernel for a distributed system of services. The idea that we can have this policy enforcement point that's not the kernel, but it's this proxy on the network intercepting all the traffic in our distributed system. And we can use one system to manage and perform enforcement on that. And critically, not just one system, but one audited code base, one concentrated piece of code to do this too, right? So it's not that we're having to re-implement these policies in every language and in every application. We implement them once, we reuse them everywhere. And so we can do security vetting on them, right? Envoy itself, for example, is the data plane that we use in the Istio service mesh. Both Google, Lyft, I believe even Microsoft and Amazon now additionally cover it with bug bounties, right? But certainly I know for a fact that Google and Lyft both cover it with bug bounties. And we've had a lot of CVEs reported from the community through the bug bounty program, right? So this is an example of things that we can do because the security is concentrated on the Envoy code base. The community can fund making sure that is secure, right? So that's how we can realize that idea, this kind of distributed kernel or this kernel for a modern distributed system.
Cool. So I got two, but two roads diverge. So we'll probably won't come back to the other one, but that's fine. So when we think about this, I'm going to jump down a letter actually to C. So because you're hitting on some DevOps, DevSecOps type constructs with this approach. I'm very fortunate with the company I work for 9 to 5 that I get to listen to a lot of our DevOps guys a lot just by proxy of updates and all that fun stuff. So anyway, so when we think about this structure, right, we think about this deal. To me, it sounds like the service mesh is where our DevOps, DevSecOps guys really, really hope to be, want to be, would love to be. Is that kind of idea? And I'm hoping, yeah, since you went ABC and you're lettering some of those standards there. But yeah, I mean, is that kind of the vibe check here is, we want this service mesh for that construct that we're driving with the new DevSecOps mentality?
Yeah, and it doesn't have to be in that mentality, but the key thing in a lot of that DevSecOps mentality and the service mesh architecture, like it's important, it's a truism, but we build software that matches our organization, right? So the service mesh came from Google. So what is the organizational structure that it is replicating? And the answer is it's replicating in Google the SRE model, and in the larger community that's turned into the DevOps movement, DevSecOps now, right? If we look at what did that mean? So inside of Google, the SRE organization has a kind of crazy mandate, and that mandate is you must grow sublinearly compared to headcount growth of software engineers. So if software engineers were going to hire like this, the SRE organization needs to be flat. So the only way that you can do that is automation and force multipliers, right? Consistency, be able to enact change on a large part. So that's really where the idea of the service mesh comes from. And so the service mesh is really a key enabler. There's no free lunch. You can't get rid of complexity, right? But what we can do is move complexity around. And importantly, we can concentrate complexity on the people that are best suited to solve. And that's really what the service mesh lets us do. So the idea is that we have a central infrastructure, and I can change one policy to enforce encryption in transit. I can change one policy to swap our PKI, for example, and move over to there's some more complexity operationally to make that happen. But, I can do cross-cutting things. And critically, the service mesh lets us empower a small group to do that. So I can make the PKI team responsible for the PKI integration with the mesh. Therefore, if it breaks, the expert's already there, and everybody else benefits. because they just already have a PKI, because the PKI integration is already done. And so when I need a certificate at runtime, it's out of the root of trust that the organization already uses. That's one example. But the point is that, the same thing for traffic routing, the same thing for operational metrics and for logging. Suppose I want to change the log format across every service. If you were going to do that today in your organization, that would take months, right? You have to go to every team, get them to change it, get them to build and redeploy. All in a service mesh, we can have the sidecar proxy that's doing logging on behalf of your application because it's looking at the request in L7. So it can do something like an access log, like an Apache access log. We can change the format of that logging globally and with one config, right? And now the entire fleet is producing logs in a different format, right? So that's what, there's no free lunch. We can't just like, hey, encryption, somebody still needs to do PKI integration. But rather than making every team in the organization learn what PKI is, learn what a certificate is, pull in the right library in their language to integrate with it, and then do the integration to have encryption and training, we can instead have the service mesh. One time when we install the service mesh, the PKI team integrates it with the PKI so that it has a signing certificate. And now it automatically handles issuing and rotating certificates for it. And any application running in the mesh gets encryption in transit out of the PKI that the team integrated with. No effort involved, right? So that's one example, but there's many in that vein of where the service mesh lets a small group tackle the pain on behalf of the whole organization. In that way, it's a force multiplier, right? And so so now we come back to the DevSecOps, movement and all. That's kind of where the service mesh came from. Yeah, it's, the app devs are still going to want to interact with the service mesh, right? Who knows what the timeout needs to be for each method of your API? What's the right retry policy by default for a client that wants to call your API? I don't know. You don't know. Like you're a security guy, you don't know, right? But the app team knows, hopefully, or at least they can make it a guess, right? And so let's let them do that. Let's let us do the security policy settings, and let's keep the two separate so that they don't have to worry about security and I don't have to worry about the traffic settings, right? And the service mesh really gives you the system to be able to do that.
Cool. I think we definitely beat that one up a bit. That's cool. I like this. Like I said, it's a term it's a term I've seen. It's a term I've looked at a little bit, but once again, you're the first person that we've had that we can really kind of dive into the idea of what it really is.
Yeah. And let me just touch on this real quick. So we talk about the service mesh a lot in the 204 series and in 207A, we talk about the service mesh. So I want to be very clear that, all the policy that we talk about in the SPs can be implemented without a service mesh, right? Those 5 policy, the identity-based segmentation, you can implement those in a bunch of different ways, right? And a service mesh is not required there. What we do think is that the service mesh makes it a lot easier to implement those things compared to most other paradigms that you could use them, right? So that the list to get there, we argue is smallest with the service mesh compared to other approaches you could take, like, doing it in the library, doing it in process with libraries, or, in frameworks, or assembling a set of different disparate technologies like BioGuard for encryption. And this, all of them have different complexity. The service mesh gives you a nice set of trade-offs.
That makes sense. Yeah. And yeah, you hit the nail on the head. I was going to ask you a few more examples on that. So when we think about, when we think about those security models and that growth, what's one tantamount thing to consider out of this current structure, the current standards and stuff? And I know there was another topic that you wanted, the other standard as well, that we want to go down, but kind of, I pigeoned us into this because of the service mesh, because I got really curious. So I'm not sorry, but let's just say, let's peel all this back. So we talk about those 5 tenets. We talk about the, phase 1, 2, 3. So out of all this, let's say if one key tenet out of all this to get started, obviously you want to go through the whole thing, but one key tenet here to get started, where should people kind of poke and prod first so then they can dive down the right rabbit hole to make sure they do eventually get through this cycle?
Yeah. So when it comes to zero trust overall, I think the NIST cybersecurity framework lays out the right thing. And by the way, the cybersecurity framework is currently undergoing a revision. The improvements are great. Check out the images. First step is identify. Figure out what are you even protecting? What's there that exists in the infrastructure, and then go from there. And the cybersecurity framework lays out the full 5-step kind of process there, right? We identify, we protect, we detect, we respond, and we remediate, right? Those are the cybersecurity activity that we need to be able to go through So start at the beginning. Start with identifying what's there. So when it comes to something like a service mesh, for example, that's a great tool. I mentioned it gives visibility. It gives you things like L7 traffic flows. That's a really effective way to start to inventory or identify what exists in your infrastructure. And not just at the level of like, there's a host with our IP address, but at the level of there's an application that's speaking and it calls these other applications on these methods with these HTTP verbs, for example. Right. So that's the place to start. Identify what you have, know what you even need to put a boundary around. Then, start to build out the protections. Right, is the next step. Things like encryption in transit, the service mesh can do. Things like a strong authenticatable runtime identity. The service mesh does that when it does encryption in transit. Then start to author authorization. So great, now you have an identity, things are encrypted. Start to author authorization policies. Start to gradually reduce the area that an attacker can attack if they compromise a workload. Use authorization policies, right? And then, overlay that with your existing identity, end user identity and authorization systems. And again, as you're layering these things in, look in the organization where there's other technologies and other policies that hurt agility and see if you can't relax those while you're adding these other controls in.
Cool. So I know we're close to time, and I think given, the mentality we have here, I'm going to ask for kind of a little pitch on your company, just out of curiosity. We already kind of went a little bit. We normally, we don't outright avoid it, but I feel like given who you are, I think you're more than worthy of the fact that you should be able to pitch a little bit about how this all folds up with where your company is personally. If Elliot doesn't think so, he'll just edit it out later.
Exactly.
So, give us, a few.
Totally fair game. Lay it on us.
Tetrate does a lot of what I just talked about, right? So fundamentally, the stuff that I'm writing about in the SPs and all that doesn't come from nowhere. It comes from practical experience that we're doing on the ground with folks like financial institutions, the DoD, and others, right? And so fundamentally, what do? We're all about taking service mesh into enterprise, and the net effect of that is going to be, helping accelerate your modernization effort, helping keep a secure posture across a bunch of heterogeneous infrastructure. Right. So you can imagine, all the controls that I talk about and all those things, those are things that we've done with customers in practice. Right. So things like how do we bridge cloud and on-prem infrastructure and mitigate those IP rule changes and things like that. How do we actually navigate with our security posture across these? How do we get consistent visibility there? And then how do we know what policy we want to put in and then enact policy on it? We do all of that using the service mesh, and that's really where we play. Kind of taking a single open source service mesh is great for one cluster. I joked, I gave the first multi-cluster demo back in 2018. And I joked then that if you only have one cluster, it's a toy, right? If you have two, you're starting to do serious business because you're available, right? But most organizations have many more. And so what we do is the service mesh in open source is really well suited for like a single Kubernetes cluster. Weave all of your infrastructure into a coherent whole, all of those clusters, all of the instances, give you a central place to control it, manage it across clouds, do service discovery, all kinds of cool stuff that you can anticipate, hey, we have a sidecar. We intercept all the traffic in and out. You can do a lot of things around traffic routing, observability, and security. We have a system that helps you manage those capabilities across your entire infra.
Cool. I'm going to go ahead and punt the ball back over to Elliot and let him at least get one more question in from his brain pan there. And then,
please.
Yeah. Well, I mean, that's such a really good spot to like wrap it up, but I don't know, maybe I'll edit this and we'll just kind of wiggle it around a little bit. Anyways, obviously you spent some time over at Google. Beyond Corp was a thing there, probably like the first proper implementation. I'm curious, like, what was anything lingering around since I can't remember when they phased that out, but like, I'm just curious, like, what from those efforts and initiatives kind of stuck around?
Yeah. So a lot of it actually we see today. So those five, the identity-based segmentation, those 5 checks, the first time I actually ever implemented those was in Google. We didn't call it that at the time, but that's what we did. Right.
Yeah.
And so that's, and so I was actually there in cloud. So in GCP was the first part where this hit. And Google had, and people may be familiar with LOAS, it's now Spiffy in open source. Spiffy is what the service mesh uses for runtime identity. LOAS was a system for service authentication. So when we talk about encryption, service auth in, service auth C, end user auth in, end user auth C, Google had a strong and robust system for service auth in and service auth Z. They were called rate ACLs. So you would create an access control list, and you could have and it incorporated a rate limit together, because you basically the two, you typically want to go hand in hand in a distributed system. So not just you have access, but how much access you have, right? And so we had that for a long time, and then we started to roll out the service mesh, and the service mesh actually originally came from the decomposition of the API gateway. So think about what the API gateway does, right? It almost universally end user auth in, end user auth Z, do some rate limiting, and then load balance for me, please. I think most people, notoriously shared fate outages, noisy neighbors, all kinds of problems with shared API gateways. So we said, hey, let's decompose that into the sidecar architecture, right? In that transition, then now suddenly internal communication has to have an end user credential, and that end user needs to be authorized, right? And that's in addition to the service credential that we already had. And so I actually got to watch kind of firsthand as we rolled out exactly the policy that we're talking about, right? Where we went from having kind of a simple and straightforward service authorization system, and then overlaid that with end user authentication and authorization, and like all of the challenge that went into that. So all of that stuff is still there, right? So that now beyond corp and that bit of it was kind of the edges. So think of everything that I've talked about today, 207A, all this stuff, it's kind of in the data center, right? Or in your data centers, in your infrastructure. The hard part, I would argue, the harder part of zero trust is like that edge out, right? So how do you do device ID? How do you do user ID? In 207A, we sweep that under the rug, by the way. So I say you need a service identity. You need an end user identity. You should have a device identity in there, and use that, authenticate it, and authorize it. That's a really hard thing to skip over. And by the way, that's where you should fit in your risk-based authentication and authorization systems and other things like that. That is where a lot of beyond corp played, right? That was in the device ID, user ID, that side of it. Quite frankly, I don't know which of that is still around at play in Google or not. I know that that's an area that they actively iterated on. The general rule of thumb is that Google publishes a white paper when that's one generation behind what is current. So I haven't been in quite a few years to be able to speculate, but I will say that the basics, that the identity-based segmentation policy, it's still happening today internally, 100%.
I appreciate the context. It's just, I think it's helpful for people to know, because whenever you start digging into zero trust, that's one of those first topics that people tend to run into. It's like, oh, this is a huge implementation, but what the hell happened afterwards? Obviously, they face it now, but it's interesting.
It continues to evolve.
How it evolved. Yeah,
exactly. Yeah, and it continues to today, right? That's one of the challenges and fun parts of being a security team and I was on the security team at Google. I mean, I work on IAM and one of those things, but they have nation state actors that they need to model against, right? Like and not all from outside the country. The Snowden leaks are one that I use regularly in slide decks, and the slide that I show when I introduce 207A and I say the attacker can be inside the network. The picture that I don't actually use that Guam example. The example that I use is actually the Snowden leaks of the NSA drawing of Google's infrastructure. The first time I ever saw that picture was on my engineering orientation at Google, where they have an engineer who's very angry come out and explain, why does the network look the way it looks? And the first picture is that. And then it goes from there, right? So a motivated attacker can be in the network.
Very interesting. I mean, so we are at the top of the hour. Zack, thank you so much for running us through your contributions on the policy side, and obviously giving some insight into what you are able to build on the heels of some of those core concepts. So thank you so much for sharing some of that expertise and insight with us. Neil, thank you for coming back safely so you can do most of the talking as per usual. I don't know how we would do this without you. So it is good to be back up and running. But yeah, so thank you, Zack. We will definitely
thank you for having me.
Wrap you back around.
Yeah, Zack, thanks, man. Once again, good conversation. Appreciate the knowledge. Thank you.
Thank you for joining AZT, an independent series. Your hosts have been Elliot Volkman and Neil Dennis. To learn more about Zero Trust, go to adoptingzerotrust.com, subscribe to our newsletter, or join our Slack community. Viewpoints expressed during the show do not reflect the brands, employers, or companies of our hosts, guests, or potential sponsors.